So you've already written down factors of 24. Can somebody share with me some of their factors of 24? What did you get? Just give me one. Somebody give me one. 12. Love it. Another one? 24? Factor of itself? Sure. Ooh, I know how to fix this now, I think. Oh, no. There we go. 24. Hopefully it doesn't happen again. Anything else? Somebody else? Come on. This is easy. Let's engage our thinking. 2. Nice. I love it. Thank you. Somebody different. Come on. Come on. Come on. Come on. 6. What do we have? At least one more? Is that all of them? I think that's all of them. Some people might be like, oh, what about 1? Oh, no, there is another one here. Yeah, you're right. What about 1? 1 is sort of a factor, but 3. Thank you. I think that's an exhaustive list. Somebody name something that's not a factor of 24. 7. What else? Just give me a few. 5. What else? 9. 1,407. Not a factor of 24. Lots of things are not factors of 24. What makes something a factor? Why are the top row factor and the bottom row aren't? Before we answer that question, something else that we can do is I can match these up in pairs, can't I? So for example, 12 times 2 is 24. 8 times 3 is 24. 6 times 4 is 24. 24 times 1, we're not going to do that one. Right? Does that work? Is that good for everybody? Can I do that with the bottom row? 7 and 9? No. So there's something going on there with what makes something a factor, what doesn't. Yeah, exactly. What's another way that we can say that? A factor of a number divides evenly into that factor. What is a new revisited in grade 12 way of saying divides evenly? Can anybody answer that question? That's kind of a roundabout question, but oh, that's not a hand. Divides evenly. Think about what we did yesterday and what we've done over the last few days. Yeah, the remainder is 0. Isn't that what we mean by divides evenly? Okay, so that's important. Just on another note, this is kind of interesting. You do this in elementary school probably, and then it's just practice. And then you never use it, you never do anything with it. And I don't know if you've talked about it since you started factoring in high school, but what can I break 12 into? Somebody tell me 2 things.
3, 4, 2, and 6.
3, okay, just 2 numbers that multiply. Pick 2.
3, 4.
Thank you. So this is like 3 times 4 times 2. And what can I split 4 into? 3 times 2 times 2 times 2, right? So there's my 4. There's my 12. So I'm just like splitting this up more and more. Can I go any further? No. 3 times 2 times 2 times 1 doesn't help because that's not going to change it. If I split 2 into 2 times 1, I could do that forever because I could do it with the next 2 and the next 2, right? So that's why 1 doesn't really help. What about with 8 and 3? Well, 8 is like 2 times 4 times 3, which is 2 times 2 times 2 times 3. And what is 6? 6 is 2 times 3. And what is 4? It's 2 times 2. What do you notice about all of those? What do you notice about all 3 of those lists?
They're the same.
They're the same. This is called prime factorization. And you probably heard about this at some point in your mathematical career, that any number can be split into a unique list of prime factors. Okay? So every number's list will be different from every other number. I hope that's obvious. If you think about it, that should be obvious. And no matter how you start breaking it down, it'll always break down to the same list. Okay? And what's interesting is when we're factoring, like when you start factoring grade 10, that's what you're actually doing for a polynomial. Breaking it down into its prime, not prime numbers, but prime factors. The things that you can't break down anymore. Doesn't that make sense? So when we say factor fully, this is like what factor fully would look like for a number. Anyway, I don't know that that's helpful, but it's kind of a interesting little thing to just think about. Any questions about that? So what is a factor? Something that divides evenly into a number, something that when you divide, you get a remainder of 0. All right. Oh, and you wrote this down. We didn't talk about this. I hope you wrote this down. This is really important. Factor theorem states that if f at a is 0, then x minus a is a factor of f at x. This is a special case of remainder theorem. What was remainder theorem? That the remainder, when I divide by x minus a, is the value of the function at a. So it's saying the same thing that we just said. If I take this as a factor, x minus a, if I plug a and I get 0, I have a remainder of 0. That means x minus a divides evenly into that polynomial, right? If I divide 3 into 24, I get a remainder of 0. It's a factor. It divides evenly. If x minus a divides into f at x, that means, like evenly, that means I have a remainder of 0. That means based on remainder theorem, if I evaluate the function at a, it has to equal 0. So how does this help us? What does this do for us? Well, if I want to find a factor of any polynomial, I can evaluate that polynomial at different values until I get 0. Then I know it's a factor. And then I can start factoring, right? Because then I can divide it out, see what's left, and I can just repeat that process to break it down into its factors. Think about what factoring a quadratic looks like. Or think about even a cubic. If I could common factor out an x and then factor what's left, right? It's that process of pulling out factors and then seeing what's left and doing it again. So for today, like we have this thing called factor theorem, but really what we're doing is like now we're going to look for values that will make my function 0. That'll give me a factor, and then I just start factoring. Use synthetic division to divide and keep going until it's fully factored at the end. Let's take a look at an example, see what this looks like. Our first example is going to be a lot longer than the rest, just to show exactly what we're doing. Highlight a couple of important things to think about. But then you're going to start doing some of this behind the curtains, not always be writing it down. Factor each of the following fully. That's important. So what we're going to start with is we're just going to start guessing values for x that might make this 0. And if you have an educated guess, do it. Right? Like take 4.5 seconds to look at that and say, is there anything about it that jumps out at me that makes it obvious what would work? The first one we look at, we won't know. But after you've been doing this for a couple of days, and we do more of this in the next unit, but by the time we're done with this, a lot of us are going to be able to look at that and be like, okay, that's not going to work, that's not going to work, this might work, that might work. Like you're going to start to have educated guesses. So when you get there, I would do that. But if you have no idea, what should we start with? How about 1? Because it's really easy to do the math for 1. And then what would we try? How about -1? Because it's almost as easy to do the math for -1. And then what would we try? What do you think? 2, because that's the next easiest. So we're basically going to start with +1, -1, +2, -2, +3, -3, +4, -4, +5, -5, +6, -6. If you get to 6, you've probably done something wrong because that's a lot of wasted time that usually teachers don't give you questions that go that far that you have to randomly punch those numbers into your question. So this is the part that we won't usually write down, but just to highlight what's happening maybe in your head or in my head or somebody's head or on your calculator as you're doing this. If I put 1 in for x, well, 1 to the 4 is 1, so this first part is 2. 1 to the 3 is 1, so this next part is 5. This next part is -29. This next part is -38. This next part is 100 plus 120. So you can see how easy it is for 1 because it's just adding the coefficients. What does that work out to? Calculators, folks, get your calculators out. You're going to have to do this. Practice, don't. It is a pain, but this is the way that this process works. There's no way around it. Jason? 60. Is that, how many people already forgot what in the world we're even doing? Is that 0? No. So, not a factor. What that actually told us is x minus 1 is not a factor because the remainder was not 0. That was what we were testing, right? X minus 1. We put positive 1 in. Okay, so that didn't work. So let's try this one. So what happens here? Again, this is really good thinking. When I do a negative 1 in particular, so negative 1 to the 4 is positive 1, so this first one is still going to be 2. But negative 1 to the 3 is negative, so this one's now going to be minus 5, right? So like in some cases, your signs are going to stay the same, but in some cases, they're going to flip. To me, this is a big part of getting used to sort of looking for those details. You don't want, again, I've seen people trying 6, trying 7, trying 8, and negative 1 or negative 2 was the answer, but they missed it because of a negative sign. And that would be an unfortunate waste of time on a test, right? So you really do have to be careful. If I square negative 1, I get positive. So this term is still negative, so negative 29. Negative 38 times negative 1 is positive, so this is plus 38. And then plus 120. What does that one work out to? Anybody done it yet? 126. Not a factor. Keep going. F at 2. So I don't know. You might be able to do some of this in your head. Let's see. 2 to the 4 is 16 times 2 is 32. 2 to the 3 is 8 times 5 is 40. 29 times 4, is that 126? No, 116. So negative 116. 38 times 2, negative 72. That's not right. 76, sorry, thank you. Plus 120. What does that work out to? 0. We found it. So once again, you would not show that every time. I mean, you can if you want. Maybe do it on scrap paper. Otherwise, your questions are going to be so long. Okay? We don't usually show that process. We do that just on a calculator. Or like I said, if you have to write some of it down, scrap paper. But this is what we do write. F at 2 equals 0. Therefore, x minus 2 is a factor. You have to write this step. Okay, and then I'm going to come off to the side here. You don't have to draw an arrow. And I'm going to factor or divide x minus 2. What do you want to use, synthetic or long division? This is where you pick your preference, but I hope everybody's preference is synthetic. So 2, 5, negative 29, negative 38, and 120. We'll bring down the 2. Negative 4. Subtract, I get 9, negative 18. Subtract here, I get 11, negative 11. Times negative 2 is negative 22. This is where you really want to watch your negatives. Wait, I did something wrong here. Is positive 22 is what I meant to say? That's supposed to be positive, yeah? We're going to check it. I don't know. I'm doing this really fast, so if I make a mistake, it's going to be obvious in a minute. I hope I make a mistake because it's going to help us out. 38 minus 22, that's 50. Is that negative 60? Negative 60 times negative 2 is positive 120. Ah, look what happened. What happened? Is that weird? No, that's supposed to happen. We picked this value because we checked, because it's supposed to have a remainder of 0. So that it's a factor, so it divides even. Like that was the whole point. Remainder of 0. There's my check. if I made a mistake in my mental math, or if I went too fast, or it would come out right there. At some point in the process, you need to be careful, right? But there's sort of that nice check to make sure that it's right. Okay, so now we go back here and we go, therefore, f at x equals x minus 2 times 2x cubed plus 9x squared. I'm reading my answer off. Whoops. Minus, what's going on here? Minus 11x minus 60 plus 0. Like, look what I have here. I don't have a remainder, so I can keep factoring this. And I'm going to get something that's just a bunch of factors multiplied together. Right? Does that make sense? Everybody okay with this so far? So here's another thing that we're going to do as part of this process. So you have to do this part. Let g at x, doesn't have to be g, I suppose. You can pick your favorite letter, equals this, 2x cubed plus 9x squared minus 11x minus 60. That's this thing right here, right? Because now we have to look for another factor inside g at x, because we have to keep factoring. It said factor fully. Why do I choose g at x instead of going back to f at x? Well, it's smaller, so it's going to be a little bit easier. There's another reason that we're going to talk about in a moment, so I'm actually not going to talk about it yet. So go try to find it. Go. Oh, do I have to test? Should I start with 1? This is something I did want to talk about. Should I start with 1? That's what we did the first time, and I said always start with 1. Why wouldn't I start with 1 this time around? Let me ask you this question. When we were looking for factors of 24, 5 wasn't one of them. 12 was. So will 5 divide into 12? Is that possible? So what were you going to say? I'm going to improve that. It can't. It can't. If it didn't go into f at x, it can't go into g at x. Think about what a factor means. If something goes into g at x, 100% it will go into f at x. Every factor of 8 is also a factor of every multiple of 8. 16, 24, 32. It has to. Think about factors. Don't waste your time on the ones you've already tried. So go. Now go. Okay, I'm done talking. Found it yet? Whew, that's a lot of work. I see a lot of people writing it all down too. It's fine for today. Trust me. You don't want to keep writing down all those steps every single time. Evie, what'd you find? Negative 3. How many other people notice that g at negative 3 equals 0, therefore x plus 3 is a factor? Anybody else find negative 3? Did you get that far? Some of you might have just been working on that one because you might have tried 2, negative 2, positive 3, took you to negative 3, but you might not have finished it yet. Okay, so now what do we have to do? Well, we got to divide that through again. So let's go ahead and do that. We're going to divide it into g at x, not f at x. Oh, what am I doing? Good. You go ahead and try yourself. Don't just copy me. It's always a good chance for you to practice. All right, I got another remainder of 0. Good, there's my check. And look at how I rewrote the next statement. Therefore, f at x equals. Don't say therefore g at x equals, because we don't actually care about g at x. We're just using g at x. We care about f. So f is equal to the first factor we found times the second factor we found times the result here. And if you're wondering why that's true, again, you can go back and think about 24 and figure out why that's true. But it is. So now we've got this done. We're good. Are we finished? Isabel, you think no? Why? Do we know that we can? How? Because it's math class and teachers always make the questions that work out. Good answer. You might be left with a quadratic that's not factorable. How do you tell? Just go ahead. Yeah. Turns out discriminant's 169. That is perfect square. This is factorable. If it's factorable, absolutely factor it. So yes, in this case, we can. And it's going to be 2x and x. And I bet it's going to be 4 and 5. Yep. 2 times 4, 5 times 1, 8 minus 5 is 3. Right? In case you didn't quite catch that, we're looking for 3x. So that's 8x minus 5x gives me positive 3x. But however you factor tricky trinomials, go ahead and do that at this step. If you like to write out the factors as an example, if you want a review of that, ask me, we'll go over it. Okay. Any questions? Are we sure? Let's try another one. We're going to speed up this process in a few different ways, because otherwise these questions get really long. That being said, if you try to take shortcuts and you start making mistakes, then you shouldn't be taking shortcuts. You go back to doing it the long way, right? Your brain can only hold so much information. So if you're making mistakes because your brain is dropping things or just doing things wrong, write things down on paper. That takes like it makes it easier on your brain, right? It takes the load off of your brain. Your brain can do the hard part, let the paper do the remembering numbers part. Okay, so we are going to speed this up, but you can go back to showing more steps if you need to, but I guess I'm going to show you sort of the minimum of what you would need to show. And I'm going to show you a trick that some of you will like and some of you won't. That will really speed things up if you get it. Okay, so first of all, what do we have to do? Anybody? Find a factor. And we'll start by checking 1. So go for it. Does anything in there jump out at you that might work? No? I notice that there's a lot of multiples of 3 here. So I wonder if 3 would work. But I'm not going to start with 3. I'm going to start with 1. I notice that some are positive and some are negative. So positive 1 might work. Negative 1 might work. Anyway, try it. Oh, you got it. Nice. Oh, yeah, good. Oh, 3 we did work. What did we find it to be? 3 does work. Interesting. What else? Negative 1. I'll start with negative 1. You could, it doesn't matter which order you do, you could do 3. Interesting that 3 worked, so that hunch paid off. In fact, I'm going to show you a little tip when we're done this that will also help us narrow down that list of things to try. F at negative 1 equals 0, therefore x plus 1 is a factor. So we have to do synthetic division here. Go ahead and do that. Yeah? It's kind of going to make the number smaller, but honestly, that's not really going to help us much, I don't think. But if you're good at hunches and you find 3 more quickly, like, go with it. There's no reason not to either. So. What are we looking for when we complete that synthetic division? We are looking for a remainder of 0. Got it? I think we're on the right track. Therefore, f at x equals x plus 1 times 2x cubed plus 3x squared minus 18x minus 27 plus 0, but we don't need that part. Are we okay? See what I mean? You got to be good at synthetic division. You do it every question, maybe multiple times, but you're going to get lots of practice, so that's good. Let g at x equal this thing. We don't need to rewrite it the whole time or every time. Okay, let's find another. Oh, we already know another factor because a bunch of you already found 3. So let's just use it. Why not? So if you found a couple, then good. G at 3 equals 0. If f at 3 was 0, then g at 3 will be 0 because I didn't divide it out, right? So that will still work. Test it if you're not sure. Therefore, x minus 3 is a factor. Okay, put your pencils down and watch because I'm going to do something really tricky here. You may have to see it a few times. If you don't like it, don't sweat over it. You can always use synthetic division. You get good at synthetic division, it's a pretty fast process. But what I'm going to show you is a little bit faster. But it's the kind of thing that, like, you know, I'm going to explain it and you're going to go, I didn't understand that. I'll explain it a few times, and if you get it, you get it. If you don't, you don't. It's hard to see. Okay, but here we go. Therefore, f at x equals, notice how I went with f at x this time, not g at x. Like if you compare it to the last example, we were still working with g at x. So x plus 1, x minus 3 times something. So here we go. What's the degree that's going to be in here? How do you know that? So here's a degree 1, here's a degree 1. This has to be degree 2 because f at x is degree 4, so they have to add back up to degree 4. Doesn't that make sense? And let's look even more carefully. This times whatever I start with, which will be x squared, has to give me that, doesn't it? This is the part that you have to see that. You have to be able to think through that yourself. This is g at x. Okay? So this times this has to give me that. Does that make sense? So what does that make this first term? 2x squared, is that right? X times 2x squared gives me 2x cubed. Is that right? Are we okay with that? If not, go back and think about it after. What else do we know? We also know that this times this has to give me what? This, which is negative 27. Do we agree with that? Do you see that? This is the easy part, but do you see that? You have to see that. Okay, so what number? Positive 9. Do it again. Positive 9 times negative 23 is negative 27. We're good. Now here's the harder part, finding the middle term. But here's what I know. Okay, so put your pencil down, just watch. Okay. The middle term is going to be x. Right? It's going to have, oh no, yeah, the middle term is going to be x. And when I multiply them, in some ways, I'm going to look at this term here. I'm going to look at x squared term first. Okay? And I'm going to write some stuff down because I'm showing it, but usually you want to just do this in your head because if you start scribbling on it, it's going to mess things up. Okay? What is negative 3 times 2x squared? So I got negative 6x squared so far. What else is going to give me an x squared term? This times whatever that works out to will be x squared, right? Any other x squared terms? You can think about it. The answer is no. So negative 6x plus something has to give me that, right? The only two x squared terms you're going to get are the red one here and the blue one. So what do I want this to be so that it adds up to? I'm just going to repeat this because the video stopped there. So we have these two. When we expand, remember, it's always about thinking about the relationship between what we're factoring and our result, and how if we expand this, we're going to re-get what we started with. We're supposed to. So if I were to expand these two terms, okay, these two would multiply together, and they would give us negative 6x squared. And then the only other x squared term is going to come from this and this. So that means whatever I end up with has to equal 3x squared, because that is this term, the x squared term. So once again, this is going to give me an x squared term, and the product of those is going to give me an x squared term. So now I can fill this in, and what does it have to be? It has to be 9x squared. So negative 6x squared plus 9x squared equals 3x, positive 3x squared. And so when I multiply it by x, I actually want this to be 9 plus 9x. And let me just fix that. Plus 9x. Okay, so I'm going to go over this. Now that we've got this, let me get rid of all of this and just think about this one more time. To get 3x squared, I'm going to multiply these and these. So I already knew this term and this term. I can figure out that term with that relationship if you see it. If not, you can always do synthetic division again. And the other thing that's interesting is you can confirm this answer. If it works for one, it'll always work for the other, but you can confirm it. What about this term here, negative 18x? Well, this is negative 27x plus 9x is negative 18x. So it'll work for the squared term and the linear term. Now this only works when you get to degree 3. Okay, we have to do that. We have to do it once at least when we start with a degree 4 polynomial, but it'll work at this point. Okay. Oh, and we're not done yet because we have to finish this off. If this is factorable, which it is in this case, then we need to factor it. Okay, and then we're done. So we've got one more here to do. We're going to do the same thing. We're going to look for a factor to start us off. So f at 2 equals 0. Somebody gave us this. Therefore, x minus 2 is a factor. Okay, so we do the division over here. Bring the 6 down, multiply by negative 2, we get negative 12. Subtract here, you get negative 1. Multiply by negative 2, you get 2. Here I get negative 10. Multiply by negative 2, I get positive 20. Subtract, I get negative 3. Multiply by negative 2. Perfect, I got 6. That's what I wanted. So that my remainder is 0. Like we expected, but we just want to confirm that. Okay, so therefore, f at x is equal to x minus 2. 6x cubed minus x squared minus 10x minus 3. Okay. Let g at x equal this thing. And so we're going to look for another factor, and it turns out that negative 1 works. Okay, and this is where we can do our trick. So if you want to watch it one more time, here we go. Oops, not g at x anymore, right? Where you can do f at x, we can go straight to f at x. F. So we've got our first one, and then we've got our second one. And then how do we figure out this trinomial? So I got to multiply to 6x cubed. That means this has to be 6x squared. I got to multiply to negative 3. That means this has to be negative 3 because I'm multiplying by 1, right? I'm looking at what I'm multiplying by here. And I've got 6x squared plus something has to give me negative 1x squared. So what does that have to work out to? Well, I'm going to subtract. I want it to be 7x squared. So it's 6x squared minus 7x squared. So what do I multiply x by to give me 7x squared? Negative 7x. And sometimes it's easy to look back after we've got our answer. So 6x squared minus 7x squared gives me negative 1x squared. And so that's the easy way, fastest way of coming up with our quadratic. And then I'm going to go ahead and factor this guy. And it's got to be 2 and 3, don't you think? So that 3 times 3x gives me 9, and I want that one to be negative. Plus 2x gives me the negative 7x. And I'm done. One thing that I want to point out that's interesting is when we started this question, we thought about what might make sense as factors, and we saw a bunch of multiples of 3, so we thought 3 might work. And take a look, there are 3 3s. So no wonder why that happened. But what I want to point out, what I want you to think about is this number, this number, this number, and this number, how are they related to that? And when you understand that, it's fairly straightforward. But when you understand that, you can recognize that when we are picking values that we're going to test to see if to find a factor, do I need to test values that are not factors of 27 in this case?